video will cover section 1.3, more on functions in their graphs, and we'll cover the first part. So today is Friday, August 28th of 2015. We're going to cover probably half of it, and then we will finish this next week. So we're going to start with going over the definition of increasing, decreasing, and constant functions. And so you already have it on your notes because I don't want to wait for you guys to write it down. So let's just underline some of the more important things about it, okay? So we have that a function is increasing on an open interval, and I want you to please be careful with this definition. If you notice, for all three cases, we're talking about open intervals. So when we give our answers, we need to consider that. Open intervals, that means that those points are not included. So should we use bracket or parentheses when we give our answers?
Parentheses.
Parentheses, okay? Always parentheses if we're talking about open intervals, all right? Don't let anyone tell you otherwise. Open intervals, okay? If the definition didn't have open intervals, then we will consider the brackets, okay? But because of the way it is defined, that's how we're going to answer our questions, with open intervals. All right, so let's go back for increasing. We're always going to be looking at our functions from left to right, okay? And so the first example, you can see it here. The function is increasing. It is going up. Remember, always from left to right. And so what the definition states is that if x of 1 is less than x of 2, and you can see that here on the graph, we have x of 1, x sub 1 first, right, closer to 0, and then we have x sub 2. So that implies right away that x sub 1 is less than x sub 2, correct? Okay. Now, the definition has this part here that says if f of x sub 1 is less than f of x sub 2, then the function is increasing. So remember here, what we're talking about is similar if I was stating the y value that corresponds to x sub 1, or the y value that corresponds to x sub 2. Okay? So what we're saying here is that x sub 1 is less. If you notice, it is lower, closer to the origin. So f of x sub 1 is less than f of x sub 2. Okay? So that will be the way to interpret that definition. Now let's look at the second one. And again, we have open interval, in this case decreasing. Our x's are going to be placed in the same way. So we're saying that x sub 1 is less than x sub 2. So x sub 1 comes first, and then we have x sub 2. Well, now, to the contrary of the first example, in this case, we have that f of x sub 1 is greater. So that one is right here. So that will be like the y value that corresponds to this x value. And here we have the y value that corresponds to this x value here. So if you notice, the difference between increasing and decreasing is like how are the y values positioned or located, where they're located at. Okay? All right, we have one more, and that will be constant. And constant, that will be that, again, and going back to constant, we have, again, open interval. And here what we're going to say is that the y values, or the function values, are equal. Now here, instead of saying x sub 1 is less than x sub 2 or anything like that, we're just saying that x sub 1 and x sub 2 could be any two numbers in the interval. And also, one thing that is not mentioned here, is probably worth mentioning, is that x sub 1 does not equal x sub 2. Just to make it clear that we're not talking about the same x value, okay? That's probably just a little thing that the definition is missing. So if you notice, the y values are the same, right? So the function is constant for this particular open interval right here. All right? Okay. Okay, so we're going to answer to state the intervals on which each function is increasing or decreasing or constant. And so remember, open intervals, so we always use parentheses. Let's just write it down. don't teach English. All right. And so you can see here, remember, we always read our graphs from left to right, okay? So think about it. If we go from here, and we're moving to the left, so I'm following the line, you can see that it is decreasing, correct? It is going down. I know you might be tempted to say it's going up, but remember, you're reading from left to right, okay? So if we were to think about the definition, you could see that the y values are decreasing. And so we're going to take that interval and also the one here. That one is also decreasing. Okay, so to answer the question, this function is decreasing on the open interval, and we're going to consider the x values, okay? To state the open interval. Okay. So the x values, we could see that we have an arrow. So we don't really know where the function started decreasing, and we know that the arrow implies that the function extends indefinitely. Moreover, we know the domain of this one, it is the polynomial. So I could tell you that it is negative infinity to positive infinity. That's the whole domain. So for the first interval decreasing, we start with negative infinity. And then here we could see clearly what is the x value at this particular point. What is it, Jennifer? X value here? 0. So only the x value. So it is decreasing from negative infinity to 0. Okay? Also, it is decreasing from here to here, and we'll see another arrow. And so that will happen from x equals 2 to infinity. And we could say union to state that we're talking about two distinct intervals, or if you want to put a comma between them or something like that, it's fine. Now, I want you to make a notation here. You are giving your answer in for x values, okay? Not points. And that is one of the most common mistakes when students answer those questions. They try to think about the points, the coordinates of the point. So don't do that. Only the x values, okay? X values when you give your answer. Open interval, we always use parentheses. Okay, so let's go ahead and answer for decreasing. I'm sorry, increasing. Oh, let me use another. So for increasing, we see that the function is increasing here, right? And so again, we're going to consider the x values, all right? So we're going to start here. The x value is 0. And then it keeps going up until x equals 2. Okay. And you could see that 2 is present here and here, and 0 is also present in both, right? 0 and 0. However, the fact that we have parentheses, we're not saying that as those numbers it is increasing nor decreasing, okay? It's simply not doing any of those. And when you take calculus, those points become really important, and they're called critical points, okay? So then when you learn how to calculate derivatives and all that, then you will learn the importance of those, okay? All right, So let's go to the next one. Do you guys want to try to do it on your own, and then we'll check the answer? All right. So I'm going to pause the video, and then go ahead and get started, and then we'll come back to check our answer. All right, so we're going to go over our answers, and let's get started with increasing. And here, you guys see there's a little turn, so I'm going to stop there at -1, and then you can see that it is increasing again here. And again, we have arrows. So for increasing, we have the interval from -infinity to -1, and also we have the interval from +1 to infinity. And I know it infinity because of this arrow here, okay? And I know that it is 1 because of this 1 here. All right. For decreasing, we have from here to here. And so you see the x value is -1 for decreasing. So from x equals -1 to x equals +1. Remember, we're only using the x values. So let's just write it down again. Give your answer. Open x intervals. It's kind of like if you were giving me an answer for domain. All right? Only x values, not coordinates of the points. All right, so I'm going to go to the next slide. Okay, so we're going to write down a definition, and now we're going to move on to relative maxima and relative minimum. So the point at which a function changes is increasing or decreasing behavior can be used to find any relative maximum or relative minimum. Okay. And now let me tell you first what the word relative, well, I think maximum and minimum is pretty self-explanatory, right? Minimum will be something like this, like the lowest point, and then maximum could be something like this one here, the highest point. Now, we know that the arrows imply that the graph keeps going and going and going, right? Now, if I were to extend my graph in this direction, wouldn't we have like a smallest y value here? Maybe something here? Yes? So that's why we use the word relative, okay? And because we're only considering a certain interval, like from here to here. For a polynomial or a function that extends indefinitely in both directions, it's just impossible to find like the absolute maximum or absolute minimum, because we know the domain will be from -infinity to +infinity, right? So that's why we have to set an interval and use the word relative. Some books, sometimes, or professors, they use the word local instead of relative, but it has the same meaning. It just means that you're picking the minimum or the maximum just for a little piece of your graph, not for the whole graph, okay? So let's look at the definitions, and we have a function value, f of a, And I want you to make a little note here. We're talking about the y value. Okay? So a function value f of a is the relative maximum of f if there exists an open interval, again, we're talking about open intervals, containing such that, containing a, this is the x value, such that f of a is greater than f of x, so meaning this is the largest y value. For all x that are different than x equals a. I know the definitions could be kind of overwhelming sometimes. They look kind of weird, but I like to go over them because as you move on, you might find a professor who might not take the time to teach the whole class, and so it is good for you to learn how to read books, especially scientific books, and particularly math books, right? So you could actually learn any math just by reading a book. So I do take the time to go over those definitions, okay? And I try to help you guys interpret them. So the next one, we have a function, value f of b. Again, we're talking that is the y value. That will be the relative minimum, the smallest, if there exists an open interval, again, we're talking about open intervals, containing b, remember b is the x value, such that f of b, so in this case, this will be the smallest y value. Okay? So again, if we look at our graph here, it's just following the definition. So in this case, we have the relative maximum was the y value at x equals a, and the relative minimum was the y value that corresponds to x equals b. All right? Now let's see how we're going to answer questions that involve that, those type of answers. Okay, so we have a graph here, and this might be a graph that you're not very familiar with, or maybe if you did your decimals project, this is the sine function. And actually, I got a pretty good picture in DC about how sine functions can be translated to real life problems. Okay, so I'll show it to you guys later. But anyways, we're going to look at just a particular interval here, and let me see, do they tell us the interval? I probably forgot to type it. Okay, so let's focus on the open interval from negative pi to positive pi. So when we do these graphs, our x-axis will be labeled in radians. Okay, if you don't know what radians are, they're another way to measure angles. Okay, but we will get to learn how to convert from degrees to radians and radians to degrees before we look into that. And also, I was telling one of my students that with Precal 1, I like to squeeze at the beginning so that we can have more time at the end. But with Precal 2, I do the opposite. I take a long time with the first chapter, which is chapter 4. Because if you don't understand chapter 4, then you can't understand the whole course. So don't be afraid of Precal 2, okay? Save your stress for later. So let's answer the question, what is the relative maximum and what is the relative minimum? And so here, of course, we're going to look at the lowest point, which is here, and the highest point, which is here. Now, the answer needs to be worded as follows, okay? The relative minimum is the y value, so that is -1. And let's say y equals -1. And it happens at x equals, what will be the x value here? Negative pi over 2. Negative pi over 2 is the equivalent to negative 90 degrees. Yes, you can have negative degrees. Okay, now the other one, for relative minimum, so that's maximum. So the relative maximum is going to be, again, the y value, positive 1. And it happens at pi over 2. Okay. All right, so that's it for relative maximum and minimum. Now we're going to move on to odd and even functions. At least let's cover the definition. Maybe we'll get to one example. So we're going to have 3 cases, actually. When a function is even, when a function is odd, and then the other one, neither. So what we will do to verify that, the process is the same for both. And you have to replace x. X is replaced with a negative x. Okay, and that's why we were practicing a little bit of that on section 1.2 to get you guys started for this one. Now, if it happens that after you replace all of that, and you end up with the exact same function, so in other words, you obtain exactly the same function, that is when you consider the function to be even. Now, the other one is if you obtain a different function, not just different, but particularly the opposite. So after doing your substitution, if you obtain the opposite of the original function, that is when you will call your function odd. And when I say the opposite, I'm going to give you a very simple example with numbers. For example, 4, the opposite of 4 is negative 4, right? Yes? Okay. If we have negative 3, what is the opposite of negative 3? 3. Okay. So if we have something like negative 2x, what will be the opposite of that? Positive 2x. Very good. Now, if we have something like x plus 3, what will be the opposite of that? X minus. Not only x minus 3, but also negative x. So you could kind of like think of it as being x plus 3 in parentheses, and then the negative, and then it will be distributed. So negative x and negative 3. Okay? So if we have something like x squared minus 2x plus 3, what will be the opposite of that? Very good. So in this case, to be the opposite, all the signs must change. Okay? Now, when something happens that we don't obtain the exactly the same, or we don't obtain the exact opposite, then that is when we say that the function is neither. All right. So how